doing a little video here on my Allied Bridgeport vertical mill, and I've already done the Y axes along with a high wind ball screw setup here. This has a high wind ball screw. I don't know if you can see the inside of there. You can see inside there. You know, it looks like crap, but this is the ball screw here. These are kind of pricey. Through high wind, I think it was like $600 for this ball screw, and then the Y axis ball screw that runs through here runs that way. So that was done in the past. I did that a while ago, probably a couple of years ago. So got the stepper motor. This is a NEMA 34. I think this is a 5 amp motor, DC motor. Well, they're all DC motors, but it's a 5 amp NEMA. This one's also a NEMA 5 amp, NEMA 34 motor that runs the X axes. Actually, it works pretty good. I had trouble with the one that was on here before. I'm not sure what happened to it, but it stopped working, so I had to put a new one on there, and it seems to be working good. It's also a one that has a encoder. Has this encoder wire that allows to know what the position is, only in one rotation though. So once it gets past one rotation, it doesn't know where it's at. But it's kind of nice, because if it does jam up for some reason, it says, you know, I'm not where it's supposed to be. Shuts the motor down and shuts the program down. So right now I'm working on the Z axis, which is the up and down, the vertical. So it moves the table. It's going to move the table up and down. This one actually is a big dog here. This one is a NEMA 42. NEMA 42. This is a heavy guy. I got this mounted on a 1/4-inch plate, steel. It's got slots. I slotted it, so I get adjustment of the belt. Some guys mount these right on the end of the shaft, which takes up a lot of room, because you'd have it like sticking like way out here. This thing would be, you know, sticking out like probably 12 inches from this shaft. So that's not good. Same here. Some guys mount them right on the end here, which ends up sticking way the heck out here. Same thing here. This would be mounted on the end here. They stick way out. So this makes it a little more compact. And even I've seen one guy there where actually he mounted this backwards, so it would be over here, but then it would actually get in the way of the Z axes, or it would actually hit this plate right here, or the part of the knee. It would hit the knee when it comes all the way over to positive X. So the way you mount them, you can mount them like this. Helps some of the dimension. So anyway, yeah, so I got this thing is this right here is the original dial, or the original crank. You can see the crank goes on there. Take the crank off, and then you have to pull this off, which is a sleeve that runs all the way down into this right here. It's a machine, and I still have to, well, after you get that off, then you pull this off. That's your graduations on there, which you're probably not going to no longer need that. And then this keyway here, that's got to come out. And then you put your Gilmer belt or your timing belt on here. This is going to go this way. It's going to go on like that. And then this gear here is going to end up going on here. I have to open this hole up to 3/4 of an inch. This is a 3/4 inch shaft. All these on the X and the Y are 1/2 inch. Or actually it's a metric. But this is like 19 millimeter, which 19 is 2/1000ths from 3/4. So this has got to get opened up, and I'm going to mount this. I'm going to put this shaft in here, but you can see the two pulleys are not going to line up. So once you get rid of that keyway right here, get rid of that keyway, which we no longer going to need that. It's going to be, I'm going to actually use a set screw and run the set screw right into the keyway where it's at. I'm going to pull that keyway out, and I think I'm going to cut back this back to that black line I wrote right on there. I'm going to cut that back, and that's going to allow me to push this thing in like another inch. Because you can see I got about probably about an inch. Needs to go in about an inch so the two line up. Get the two belts lined up, and then here's my my belt's going to go on there like that. And that's the hardware part of it. Well, part of the hardware. And then once I do that, I got the 4 wires. 4 wires. These are A and B. A positive, B positive, B negative, A negative wires. And those are going to get wired to my my stepper motor controller, which are inside my box here. It's going to actually replace this unit right here. This one actually is going to be a different stepper motor driver, and I'll go through that when the time comes. So that's the beginning of my my Z-axes. I was going to mount the Z-axes on the end of the quill, which I had made this. This actually mounts on the end of this shaft right here. This goes right in here. Yep, right there. And I was actually going to mount that motor, that big motor, I was going to mount on the end of this, which I think that would have been way too much sticking out. You can imagine it was sticking out probably this far. It's like a foot and a half from the motor, the machine. It's just not going to work that way. Plus, you only get like 5 inches of travel up and down, which on most cases, 5 inches is a lot. You don't need that much for making stuff. But let's just say you did for some reason. You're going to need more. And once you run out of travel, then you're pretty much screwed. So this is going to get me, this running on the knee screw. It's probably going to give me, those ways are probably, there's probably about 14 inches of travel up and down. So 5 inches versus 14 or 15 you got triple the amount of travel up and down. So that's going to make it a lot better. And hopefully that motor, that's a 5 amp motor, puts out 4,200 ounces of torque, which is, I think, it's 30 Newton meters. 30 Newton meters, which is quite hefty. And it runs on 120 volts. Instead of you don't need a power supply to run the 60 volts DC. These are 60 volts DC to run these motors. So you're not running it. Actually, it runs on. It doesn't need a power supply. It runs on direct. Runs on AC. I guess that's an AC motor. So anyway, I'll do another video once I get this mostly finished up here. So hopefully this will go out to quite a few people. Help with their little retrofitting the Bridgeport mill. And then also I want to show also what I did here is this is on a magnet. It actually mounts right here. And this is it's a mister. And it's flexible. Mount that like that, and then this will mount like that. So you can see this magnetic base here. And then I put this tip on here, and it blows air and oil at your part. And then that is solenoid right here. This solenoid right here, it's got a little LED light on it. Solenoid is activated through my my MB3 breakout board, which is, this is the MB3 breakout board here, and this is the wires for it. There's a few things that you have to look up to run that. There's an air supply for it, and here's your coolant, right? I mean your oil. Fill that up with actually I put Tap Magic in there. It's a cutting fluid. That works really awesome. You got to get one of those. The bad thing about it is the coolant or the oil and shit. You got to have a vacuum behind the spray, because it'll fill this garage up with like total dust or total smoke, or like a mist, like oil mist, because that's basically what this thing does. It sprays oil mist at the part. So you got a vacuum running behind here, and that's what this right here is what I made, and that mounts into right into this hole right here. And that captures the debris and the oil dust or oil mist, if you will. And that works really good. Captures all that crap coming off the cutter bit. In the mister, too. They call it a mister. So that pretty much solves a lot of the issues with cutting fluid and the keeping the bit cool. Actually, I put a hole saw. I had to drill. That hole saw is actually for this hole I drilled in here. This plate here had a cutout here, and I'm glad I was able to use. It didn't interfere with the 3 bolts holding this up. But this should be good to go here soon. So you got Z positive, Z negative. So anyway, yeah, we're going to finish that up hopefully today or tomorrow. And I'll be able to do another video. Alright, well, don't forget to like and subscribe to my video. So, yep. They got a bunch of other machines in here. Hone, quick way hone right there. Cap cutter. Got my grandpa's lathe right there, which my dad had it. My dad had it, and then my grandpa had it before that. Got a valve grinder. Honing. I'm also honing an engine block right here. I got one side done. This side hasn't been done yet. That's actually a Mercury 2-cycle 6-cylinder Mercury outboard motor that I'm honing. So I got a few things going on here. So, all right, have a good day.